Hi, and welcome to the first of, hope you're sitting down, 5 videos for section 10.3. We skipped 10.2, right? We went 10.1, 10.8, 10.9, now we're going back to 10.3. Section 10.2 is solving linear systems with 3 or more variables. I'm skipping that section because for 2 reasons. One, we're going to do the same type of operation, substitution or elimination. That's one of the possibilities. The other way that we can solve systems with more than 2 variables is what we're learning here in 10.3, which is matrices and how they correspond to systems of linear equations. I don't know the total time for these videos. My guess is that if we add it up, it's probably going to be more than an hour and 15 minutes. The good thing about that is that's why we do the flipped class. If I was trying to get through all of this material in an hour and 15 minutes, I'm not going to be able to explain it very well. I'll have to kind of rush through it. Sorry, I can't take any questions. We got a lot of material to get through. Here, I'm going to go at a pace that will hopefully help you understand it and learn it. But now you have to bear with me. So yeah, I know it's probably more than an hour and 15 minutes, but for all the other sections that have all been less than an hour and 15 minutes, this is where I have to make you sit around for a little while longer. But again, I promise you it'll be worth it. It's going to make life a lot easier on you for the rest of this section. So section 10.3, as I mentioned, is matrices and systems of linear equations. So first, let's get some definitions here so we are all talking about the same thing. First, a matrix is a rectangle array of numbers and we can represent a linear system by a matrix called an augmented matrix. So for example, if I had the linear system 2x minus y equals 5 and x plus 4y equals 7, I can write this as an augmented matrix just by using the coefficients and the constants. So 2, negative 1, 5, and then for the second one, 1, positive 4, positive 7. So this linear system can be written as an augmented matrix just by using the coefficients and the constant values inside of these brackets on the side. So another definition. An M by N matrix is a rectangle array of numbers with M rows and N columns. So for this guy here, I have what? 2 rows and 3 columns. So we would say that this is a 2 by 3 matrix. 2 rows, 3 columns. So in the general sense, And we call each of these values inside elements. So this would be A11, row 1, column 1. A12, row 1, column 2, etc., all the way up to A row 1, column N. And then we have what? Row 2, column 1. So that's 2, 1. Row 2, column 2, A22, etc., up to A2N. And this keeps going, and how many rows do I have? I have M rows. So the very last one's going to be row M, column 1, row M, column 2, all the way up to row M, column N. So this would be A11, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3, which is our 2 by 3 matrix. So, quick little example here to test your understanding, and that'll wrap up video 1. So even though there are 5 videos, I still try to keep them short enough so that if you have to access something, you can find what you need. So, the example, we want to write an augmented matrix for the following: 6x minus 2y minus z equals 4. So we have 3 variables, right? So this is, up until this point, we've only been doing systems with 2 variables. Only been doing systems with 2 variables. Now we can have as many as we want. So this one has 3, x, y, and z. And then x plus 3z is equal to 1. And 7y plus z is equal to 5. So you remember the example I erased here. Our first column was what? That corresponded to our x values. The second column was our y values. Now I need a third column with z values, a fourth column with the constants. So I'm going to rewrite this and keep everything in order. So I have what? I have 6x minus 2y minus z is 4. Then I have x, there's no y here, plus 3z. So if you want to write in 0y so you keep it straight, that's fine, equals 1. And then there's no x here. 7y plus z equals 5. So my augmented matrix for this would be what? 6, negative 2, negative 1, and 4, corresponding to the coefficients and the constants. And then 1, 0, 3, 1. Then 0, 7, 1, and 5. So I have a what? I have a 3 by 4 matrix, which corresponds to that system of equations. So that's it for video 1. Kind of a definition. What is a matrix? What are we talking about when we say we have an augmented matrix? And then how can we convert from a system of linear equations into that augmented matrix? The biggest key being that if we don't have a variable there, we have to put in a 0 as its placeholder. So come on back and we'll look at video 2 for section 10.3.